What's up? What's up? Gotta turn down the music. Alright. How's it going? How's it going? Let me check my audio real quick. Nine. Oh. Okay, audio should be fine. How's it going? We're doing server components again. Exciting, right? Okay. Do I share my screen from here or from OBS? Not sure yet. Probably gonna share from here. Not slides. Share my screen. Huh. I guess this allows me to share everything instead of... Yeah, I'll have to share my entire screen with this, which means I'll have to probably move the stream. Yes, I am using StreamYard today because we have a guest. And until then, I'm just working on my stuff. How's it going? How's it going? Drop some ones in the chat if you're here. Let me see. Is there anyone watching on Twitter? Should probably have the chat open. Okay. Chat, chat, chat. Here. How about chat? Okay. Gotta remember that Twitter doesn't remember the chats, doesn't store them. Which is very annoying, honestly. Okay. All right, we are talking about streaming stuff. Let's see. I'm still working on my slides. So if I can move this here, I can just... I'll just share the whole screen. Or I can just share the tab. Not tab, window, I mean. This one. Lots of coffee. Way too much coffee. We have coffee everywhere. All right. I can make this smaller, somewhat bigger. Okay. So hoist data, render on the server, initial load, let it stream. And for this one, I have a different image. That one. And we call this stream UI. Stream the UI as it is available. Is that too long of a title? That seems too long. Stream the UI. Stream as it's available. We'll go with this for now. Okay. At some point we'll have to get into or talk more about server components. Not sure when that is yet. It's like this is a great size to fit into StreamYard. There we go. We'll try to stick to that. Okay. And let's see, show player. Going to, do I have 1080p on this? I do not, just 720p. That's fine. Shouldn't be too big of an issue. All right. What else did I have here? So, talk about streaming. I'll have a kind of a quick history lesson. Quick streaming history. Okay. So we'll talk a little bit about streaming. We'll also have to talk about Core Web Vitals at some point. Core Web Vitals. All right. Implementing. Hey, how's it going?
Good.
Thanks for joining today.
Absolutely. I love the rock music going on.
Thanks. Is it too loud? Should I put? I don't have headphones on, so I'm not able to really hear it.
No, it's fine. It's not distracting me, if that's what you're asking.
Cool. All right, then how are you doing today?
Excellent. Doing good. It's good to be back. It's yeah, feels good to be back. Feels good to be relaxing and not traveling and not partying in Miami. So.
For sure. I'm still oh wait, there. Still have the React Miami shirt on.
Oh, nice. Yeah. Those are super comfortable. I'm a big fan of them. So, yeah.
Cool. So we're already live. Let's see. I feel like I'm also competing with a bunch of other streamers that happen to be live right now. So
okay.
Yeah,
so only the smartest will know to join this stream.
Yeah, I don't know. Ryan Carniado is live somewhere else, so.
Okay, that's understand. You got good competition.
Yeah, a lot of smart people show up whenever he's live.
Yeah,
that's really interesting to see.
Okay. How long have you been doing streaming?
So, I started about pretty much last year, this month in April. I think April was my first stream, but I haven't really been streaming much. Kind of very rarely. I could never really set a schedule, and I had a bunch of things going on at the same time. So which is why I also couldn't really make YouTube videos, I really like making YouTube videos. I've made also another thing that I haven't done a lot of. I've been doing it for about 2 years, a little under 2 years now, but just here and there somewhere.
Okay.
Really hard to find time for it.
Yeah.
Honestly, really hard to find time for anything for me. I'm just horrible at time management. Shouldn't blame something else.
It's all good.
Yeah, but I'm trying to if I'm basically take anything that I'm already working on, and if I can just stream that's usually nice content, or I guess easy content, not nice content. Still have to put in a bunch of effort to make it actually nice. And were you looking to get into streaming, or have you been live streaming at all?
A little bit. Not live streaming. I've recorded videos related to Isograph, and I have now a proper microphone, which I'm not using right now. I apologize. It's in storage.
Oh, good.
And yeah, I want to do the same thing. I just want to give people some video content so that if they decide to contribute to the project, They can see like, this is what the setup looks like. This is how I expect you to, like, if you have the tooling set up correctly, here's the experience you get. So like, if you are like manually finding and replacing things instead of using like the Rust analyzer tool to, replace things, like there's a way to be more efficient, I guess. Because I imagine a lot of people join projects and they like feel awkward about asking questions like, oh, should this be auto formatted or something like that, or I'm auto formatted differently than you. Like, why is that the case? Like, and then they won't like say anything, and they'll manually fix up they'll look at the CI and be like, this is here's the 20 places where it added an empty line. So let me just remove those and not run the incorrect auto formatter. And like, that's like tremendously wasteful. So I think that like video content is a good way to sort of, it's high bandwidth for all the stuff that isn't specifically the framework itself. You know what I mean? Right. Like all the stuff around it.
Yeah, definitely very helpful.
Yeah.
And since we are talking about Isograph, do you want to do like a very quick introduction for people who might be watching? And like, I guess I can quickly start there. The way I found out about you was watching a talk called Reintroducing Relay, which is a talk I revisited multiple times, especially in production for the talk that I'm preparing right now. And that was my first introduction. Then I watched you present Isograph at GraphQL Conf, also a very interesting piece of tech. I'll let you fill any holes in there.
That's actually really cool that you heard about it before the GraphQL Conf talk.
Definitely, yeah.
Oh, I guess you said reintroducing Relay. Yeah. I mean, I've actually been working on Isograph for basically the same amount of time that you've been streaming, so since April.
Nice.
So happy 1 year anniversary.
Yeah, same for you.
Yeah, I found that like going on podcasts and other things seems to be a pretty effective way to reach an audience that I otherwise wouldn't be able to. Like, I'm not every day on Twitter. Well, I am every day on Twitter, but I'm not effective at it. And so I think that like that seems to be the most successful, the most effective use of being on camera and stuff like that. But yeah, if folks are familiar with Relay, it is like Relay, but in the words of one person who is trying it right now, let me see what they said, with a tremendously better developer experience. I actually don't have the quote in front of me, so that's a paraphrase. But I'm quite happy that somebody, I did not pay them to say that, has said that. But yeah, it's like Relay with a better developer experience. You can think of it, if you're familiar with GraphQL, like the way you do composability in GraphQL is you spread a fragment in another fragment. So you might have like the homepage fragment that spreads the header fragment, right? And the header fragment selects whatever data is needed by the header component, and then you do that.
Right.
Isograph, the main way it differs from run-of-the-mill GraphQL is that every component is exposed as a field. So if you're on the home page, which is like, let's say on the query, you might have a query.header component that is then exposed as a field. So you then select that directly, and once you read it out, what you get back is a component that you can render, and all of the data is automatically plugged in for you, or piped, I guess. So the idea being that your entire app will look like these fields that you selected from the graph. So your homepage might select the header, body, and footer. Header might select the avatar. Avatar might select like the user. It'll select the user's name, image, and email or something like that. I'm just like making fields up. And it's like sort of all the way down, and then you eventually reach fields that are defined in your GraphQL schema. And then Isograph has a compiler, so it scans your code base for all these and creates a network request that includes all of the data that is used by a given screen. And then at the root, you make a single network request, which is awesome because basically we're trying to avoid network waterfalls. Maybe something that you'd be interested in, avoiding network waterfalls.
I'll
make a single network
like
request
just one quick second. I need to
waterfalls. Yeah, go for it.
Yeah. I need to turn off my window AC, which is making a bunch of noise. The maintenance people have like basically dug out the HVAC system in this apartment, so sometimes it gets hot. But,
nice. Okay.
Yeah.
Yeah.
Sorry. Yeah, you were saying.
So what I was saying was that, yeah, so we make a single network request at the root that fetches all the data for a given screen. That's good because it avoids network waterfalls. It also is good because it has implicit deduplication. So like maybe your header component might select the user email, and your footer component will also select the user email.
Right.
That will only, the GraphQL server will only grab the user email once in the combined, because it merges to the same place in the combined query.
Right.
So that's like sort of the basic developer experience improvement that Isograph gives you. It also unlocks like a bunch of performance stuff, which is not currently necessarily possible.
Okay.
For example, if you defer a fragment, which in GraphQL land means you instruct the server to send it down when it's ready without blocking the parent fragment. So you might say like, I really need the home page, but like I know that the footer is really slow because we have to calculate a bunch of stuff. So I'm going to defer that. And that's nice because footer is off screen, you might suspend, and like the user doesn't really care if it pops in later, right?
Right.
It makes sense in general if you are deferring the footer fragment to also asynchronously load the JavaScript for the footer. But that's two separate steps in every single other framework, because the fact that the footer is reading the footer's data is completely coincidental in every single other framework, be it Relay or Apollo or Urkel or whatever. So there's just a whole bunch of other optimizations that we can do in Isograph, such as always asynchronously loading the components if the fragment itself is deferred,
Right.
that it's going to unlock. Anyway, that's just like kind of a taste of the things that that Isograph solves. I would encourage your viewers to check out isograph.dev, and yeah, and then also like search for Isograph on YouTube or Isograph GraphQL on YouTube. There's an Isograph company that currently is dominating the search results, which you know.
Of course.
If you click on my videos, we'll change that. Yeah, all in due time. So that's the current state, the current TLDR of Isograph.
Right. Yeah, so it's almost like you're a generation ahead of Relay, because Relay, you can like you can create fragments in like any component, and at compile time, like Relay combines them together, right? But
yes.
And it can like fetch all that data together, but it's still is Relay also a router, or do you use it with like a different like can you use it with any React routing library?
It is
How does it know
not
like which
a React
component?
router. It is not a router.
Okay.
At Meta, Relay was tightly integrated to the router. So the router would do things like preload the data and JavaScript for a given route that you are about to navigate to. If you, let's say, hovered over a button.
Yeah.
That all needs to be done by the user. Like there's no sort of blessed solution for routing with Relay, which is a bit unfortunate. In my opinion and my experience, the TanStack router is, at least when I last looked, was the best suited for use with Relay because it allows you to preload resources. Don't remember if it lets you dispose of those resources afterward, but like the two things you want is essentially, I mean, what you want is a map at the top level where you have a bunch of preloaded things, preloaded routes, so preloaded entry points. So the data plus the JavaScript for a given page preloaded. Or if your server does not support sending down JavaScript in this way, which is also something that's like you have to manually implement, then just think about this as like preload the data for a given page. And then however you download JavaScript will just also continue to work.
Right.
So you really want a map at the root of your application that says like, here are just the routes for which I have preloaded data, and then some way to dispose of those routes and garbage collect that data once you are, reasonably sure that the user is not about to navigate to that page. So maybe with like a 5-minute timeout after it has been loaded and it's not currently mounted or something like that. Then you can do all sorts of interesting things like preload data for pages that you are about to navigate to. For example, if the user hovers over a button that goes to a given page, you probably want to start preloading the data for that page.
Right.
And then what the router needs to do is look in this map, see if if the data the query reference for a given page has been loaded, and if so, use it. If not, load it and then render the component.
Right.
So this is all doable with vanilla Relay, but like it is kind of, I think, not ideal that you have to do it yourself. Like there really should be a blessed solution, and maybe there are some, but it is not sufficiently trumpeted that even I don't know about it. So
right.
Yeah.
And so yeah, usually a router, whenever you hit a page, it would load the data, it would load the JavaScript, it would render the page, and so load the data. That's the part where Relay comes in, and where it can reuse any existing data that's in the cache, or only load what's needed, do it all together and in parallel. But what I'm hearing is that with Isograph, the router doesn't even load any JavaScript, or maybe it loads some JavaScript, but Isograph is also responsible for fetching the JavaScript, for fetching the components that are required to render those fields, except for like doing it independently with with the router. Or is Isograph also a router?
So Isograph doesn't really have a good router story at the moment. So this is all like
Okay.
sort of theoretical and more like the direction that I want to take it. Right now, you just render a component. Well, you can just fetch queries, right? You can just fetch fields. Those fields have data and are associated with a function. That function is a component. So essentially, you can load something that is the home page, and that is then you then render it, right? And that rendering may suspend. And the ultimate thing that I want Isograph to be able to do is I want all of these entry points, which is to say the fetchable components, right? Like the home page is a field by itself if it's included in another field, right? Or I mean, let's say the user avatar, right? That's a field that you would include in another field, right? And home page is that other field that would include the user avatar. If that home page is fetchable by itself, which is to say, like you can make a network request to get it, and it's JavaScript, then it qualifies as an entry point.
Right.
So I think what I want is essentially a list of entry points. And that is just like how, and the router doesn't know anything about these entry points. They're just like these opaque things where all we do with them is they give us back some sort of JavaScript and we render it. I mean, it gives us back a React component and we render it. And then like that is, I think that would work with most router solutions. I think an ideal router solution does something slightly more interesting, which is that what you actually load is opaque to the router, and then there's just some sort of like there's just some sort of opaque to the router mapping between what is in the URL bar and what entry point you are currently looking at. So like you can imagine the URL as some sort of external state, right? Like, and it's not something you can control because the user can always modify it themselves. So in order to integrate with the URL bar, what you need is some way to send messages to the URL bar saying like change to this, to modify the URL bar, and also to receive messages saying the URL bar has changed in this way. So like the router here sits like it sits somewhere and it has like here's what I'm currently rendering. It has some sort of internal state about what is currently loaded and stuff like that. And then it just receives messages from some sort of external thing that can then get transformed into like, hey, maybe we should be showing something else. So I think that the router should be extremely dumb, and Isograph is kind of fits that nicely because entry points are like a fully encapsulated thing that you could just say, okay, now just like pass this to whatever.
Right.
And anyway, so that's one thing, but in the extremely long term, a route is simply a mapping from some sort of URL state to some sort of component, right? But like that's not the only state that you necessarily want to include in the route, right? So for example, you might have the same route, but if you're building for mobile, then the avatar component that you receive, like maybe the image will be smaller than if you're building for desktop, right? That in an ideal world, you might want to be able to go to /user/dev and see different content, right? Based on like whether your user agent is like I'm on mobile or I'm on desktop. Likewise, if you're building for a unit test and you navigate to your user page, then maybe the avatar component doesn't actually contain an image, just as a div with a data ID equals avatar, something like that, right? So I think that the next logical thing that routers should do is to essentially be bundlers. So that's where I actually think that isograph will end up, which is that like isograph is some sort of like is somehow related to a bundler where like you build with a certain things. One of those things is the URL, and things like say, because I know I'm building for mobile, I'm sending down less data or something like that. And then it kind of makes sense to think about like, should there be a server running where like if you make a request for something we haven't encountered, we just redo that bundle at that point in time, which is exactly what happens at Meta. Like if you go to a page, like the things that you get for going to that page may or may not be pre-computed, but a lot of them can't be pre-computed because there's an ID in the URL. And like depending on the types of, like let's say you're looking at a given feed, depending on the types of items that are in the feed, like you might encounter a video item, so you might need the video player. You might encounter a poll, so you might need like the poll renderer component. Depending on what types of newsfeed items you actually encounter, that controls what JavaScript you get down. So it is also just like probably not doable to make all of these bundles in advance for a sufficiently complicated app. So like it makes sense to think about a bundler that is running that has intimate knowledge of isograph, saying like, oh, you're trying to build this entry point with these other parameters. Let's build it really quickly, flush out what all the JavaScript is that we're going to need to download, send down the data, and so on and so forth. Yeah. So that's just like a brain dump of my ideas.
Yeah, and I feel that's probably a nice segue into server components, where one of the, I guess, key use cases that was talked about was pretty much this, where you hit a page, but you don't know what components it's going to render. So instead of sending a bundle with all the components that could potentially be rendered, we just render on the server, so we know exactly which components were rendered, and only those need to be lazy loaded and hydrated in the browser, right? So, okay, random side question here. How long were you at Meta?
Like 3 years. So 2019 to 2024, 2023?
Okay.
3.5 years. 3.5 years.
Right. Very recently. There's kind of an urban myth about a certain document called "What Comes After GraphQL." I've never been able to like get information about this this urban myth out of people, especially those who worked at Meta. But I'm wondering if if you know anything about it, or what's your thoughts on it.
What is in this document? I don't remember it.
Okay, so I mean, from what I know, it's the document basically like is the conception of server components. Like the idea was that we want to achieve a lot of these cool capabilities that Relay has, but we don't want to bring in GraphQL. So if we are just running a server anyways, let's just render our React components on the server so that we know what data was needed, or what components to send over. Right, so, something like that.
I haven't read it, so I don't know. I'm curious. Okay. Cool. I'm curious though if you ever get your hands on it. It should be released in the public record. It's like,
yeah. I don't think. I don't know if that's gonna happen anytime soon. But I guess like have you played around with server components at all? Like, what are your What does it achieve? Does it like bring something beneficial for you? Is it like a use case that you're concerned about?
Basically, I can answer no to all of those questions.
Okay, cool.
I've not tried them out, not concerned about them. I think that they're lacking in a very specific way, which
Okay.
is that you can imagine that a graph, like a DAG, maybe,
Right.
of stuff that your app does.
Mm-hmm.
One of those things, like at the very top level, one of those things will be like render the homepage header, and another top level thing might be render the homepage body and footer. But like maybe both the header and the body. I mean, homepage is like it's maybe a poor example. What if we just like talk about a blog
Okay.
header, blog body, and both in the header and in the body we select the author's email, and like due to a poor architecture design, like that takes a long time.
Okay.
Right? It doesn't make sense to me to think of the user email, I mean, only of the header and the blog header and the blog body as like the things that we can server render. Like conceptually, in this hypothetical example, it's actually the email that should be server rendered, and then the results sent down to the client. So I'm trying to think of maybe there's a slightly less convoluted example, but none comes to mind.
I have like a couple demos, examples, things that I have for my talk. We can, I guess.
Cool. Yeah. Happy to
start
do
there,
that. Yeah. But I guess my TLDR is that like you imagine like it's this big old tree. Anything in the tree might be a suitable target for pre-calculation. And React Server Components, from what I understand, only lets you target like the outermost layers for pre-calculation. And therefore, you have weird situations where like you need to refetch everything on a mutation because you don't know that like the user email field, which is mutable in this hypothetical now, like is used by both components. And so like because you don't have that graph of like these depend on the user email, you don't know that you need to re-render anything that's downstream of the user email. And so the only thing, everything could be downstream from the user email because so you have to sort of refresh the entire page whenever any mutation happens. I think that's a bit unfortunate, and like I think that honestly, like if the tooling around something like GraphQL improved sufficiently, then it would not be a question of whether you would want that functionality. You probably would default to wanting that functionality. And then there's a lot of situations like marketing pages where like you probably don't want that functionality because nothing's mutable, and like it should also fall out of that sufficiently good developer experience where like if you're not using a feature, it's like not included in the bundle and so on and so forth. That may be like logistically difficult, like because JavaScript is kind of a loosey-goosey language, but in theory, even the more performant things like marketing page, performance sensitive pages like marketing pages should fall out of this same, sort of same way of looking at things. Yeah, I guess it's like I think about this like Git, right? Like, what's the minimum number of developers on a project before you think Git is a good idea? I mean, like Git is for multi-version user control, right? Like clearly it's more than one. No, it's one. Right? Because we're sufficiently, I mean, Git doesn't have good developer experience, but like we're sufficiently familiar with it, right? That like, you know, that like me today, me tomorrow, me in some other state of mind, right? Like we're all different people essentially for the purposes of Git. And it's very beneficial to be able to like do some changes on a branch or whatever. Same thing is true for something like Relay or Isograph or GraphQL, where like the key win is that like you can edit things independently without like loading the whole thing into your head. And so you on Friday afternoon are essentially a different person than Monday, and you're thinking about a different problem, right? But you still want to be able to iterate on those independently and have stuff just continue to work. Yeah, okay. So that's my blurb about somewhat related to React Server Components, but maybe not.
Yeah, React team really doesn't want us to think in graphs. They've made that very explicitly clear.
Yeah.
Yeah, and I guess that's also going to make this a very interesting discussion, because I kind of like barely touch on GraphQL Relay. Like, I added a slide for it. I'm planning on like talking about it for a bit, but I think overall, like my conclusion of that little GraphQL segment is going to be, if you have other use cases for GraphQL as well, or if you already have GraphQL, please go pick up Relay and get all the performance benefits and never have to think about stuff like waterfalls again. I guess almost never. But if you don't, like, don't go towards GraphQL because you just want to eliminate some loading spinners. That's kind of, I guess, the conclusion that I'm going for. What do you think about that?
I think that the benefits of GraphQL certainly accrue more to large organizations, and it is easy to get GraphQL wrong and bake in a lot of bad practices. So, like, yes, I don't think it's a trivial choice to adopt GraphQL, and so yes, I think it makes sense that you should probably have a concrete reason that you will win from GraphQL, or prior experience doing GraphQL or something or other. But like, I think that a lot of the time people adopt GraphQL in a poor way and then end up concluding that the juice was not worth the squeeze.
Right.
And like, I think I would quibble and say that like, the problem there is not you didn't have a need for GraphQL, but I think the problem was more like you adopted GraphQL poorly. So, you know, that's my opinion on whether GraphQL is worth adopting.
Yeah, I feel that, because I have that same sentiment towards people trying out cloud, or like going towards a more cloud native architecture, especially if they're doing things with like lambdas and serverless, because again, it's really easy to make the wrong choices there.
Yeah.
All right. So I guess a quick context setting for people who might not be familiar. I'm designing a talk that I'm going to actually give this Thursday, or this Friday, actually. This Thursday and Friday. Thursday, I'm giving it at a meetup. Friday at the conference. So pretty fun. The talk is called Streams, Not Waterfalls. I have like some AI generated image on every other, basically like every second, third slide of it. I'm trying to experiment with AI images. So I'm going to like, I don't have all the slides yet, but I'm going to like kind of quickly run through them and whatever ideas that might pop up. This has a bit of a contrast issue, but anyways, I'll work on that. I like to say, hi, I'm Dev and I'm a dev.
Do you want to just, so how do you want me to do this? Do you want me to interrupt you, or do you want to just like,
feel free to
give
interrupt.
The talk? Like,
I don't really have like the full structure of the talk ready yet, so I can't really like give the whole thing.
Okay, yeah. So just go through the talk. That sounds good.
Yeah, I'll go over it like what I'm kind of like talking about placeholders. Like, this is a placeholder, or this is what I'm going to talk about. Maybe bring up whatever I can think of, but I don't have like a solid structure or things like monologue for the talk yet. But I definitely want to start with client rendered apps are awesome. That's kind of to shut up anyone saying like, hey, just use Rails, the problems are solved. So we want client rendered apps, and Ajax is, or like being able to fetch something from the server asynchronously on the client, was really the enabling point of like this client rendered application movement, and being able to build dynamic experiences on the web. But it was also kind of a foot gun, and this is where I can talk about making too many requests, or making requests in serial and just waiting for loading spinners all the time. Or I guess I'm bringing that up later. So here's kind of what the user or the browser looks like. We load the initial document, and then we're just stuck loading JavaScript. So this was how a lot of I guess initial SPA like single page app development looked like, because we just had an absurd amount of JavaScript being loaded before anything can be done. So we got dynamic imports, we got code splitting, we got react.lazy, and that helped with a lot of that. I've removed the document here because the document we always have to load the first document anyways. So I'm removing that from these charts for simplicity. But now we can load some JavaScript, and then which is the initial bundle, maybe the router as well, and then we load the JavaScript for the current page that we are on, and then we show it. So that's kind of what ended up, or this like helped us improve that experience. But then we just have spinners everywhere, because once we have the JavaScript for the page, that's when we go and fetch the data, and maybe rendering the component, we figure out that there's more data that needs to be fetched. So this is the waterfall that we end up creating in our applications. And when you navigate to a different page, even though the initial JavaScript is already loaded, you still have this waterfall every time you navigate across the app. And we just end up with loading spinners everywhere. But we like the composability. We like being able to co-locate the data dependencies of any UI, of any React component together, because it's flexible. We can do that pretty much anywhere. It's composable. We don't have to deal with like two different systems. We always just data UI, data UI. This is a slide that I have to practice maybe a lot more. I want to make a really strong argument for, in favor of this co-location, especially with the crowd that I might be like looking at, and the fact that if you have 100 components on the page, probably the simplest thing to do is let them define their own data dependencies, so you don't have like one, or like you don't have to figure out where the data is fetched, how the component asks for it, or which components ask for it. Being able to just do this in the component is really nice, because we never have to think about it again, and it allows us to fearlessly refactor things, move something from here and there, and it still fully works. Again, like I'm ripping a lot of this out of your talk. But again, composability could also be a foot gun, because in React, you're only going to make this fetch once this component starts rendering. So if something above it blocks it, we're not making a request anymore. So we have to finish rendering everything on top of it, then get to this component, and now we fetch the data, which is basically how we end up here and causing these waterfalls. I guess we can do hoisting. We can routers have supported this pretty much forever. You can use React Router, Remix, TanStack, pretty much anything, Next.js these days. All of them allow us to like pull the data fetching out of our component and export kind of a top level function where we do all the fetching, and then whatever components need the data, they just call a hook and they get the data that's in there that was fetched in the loader. This is kind of the opposite of composability, because we now have to make sure all the data is there in the loader. It's disjointed. We don't know which components depend on which data until we go digging into the source code, and we lose the ability to refactor. What if, let's say I want to add a new component, I need to make sure that I need to go up to the appropriate loader, make sure that data is fetched. Or maybe that data is, or we're already making a query, we just need extra fields. So now we have to decide, do we want to make a new query, or do we want to just update the existing query to make sure the fields we want are also in there? Or maybe we are removing a component and so we want to go up there and remove that query that the component was depending on, but now something else breaks because we didn't know that there are other components depending on the same data. So all of these kind of problems kind of start to pile up with hoisting. But it's really nice for performance, because the router now knows what data is required for each component. So after loading the initial bundle, it can fetch everything in parallel. And then every time you navigate, this is the only thing that happens. You fetch all the data, all the JavaScript, always in parallel. I might also add a section here to talk about like nested routing, which kind of like helps with composability, because now you can have multiple routes and all of them have their own loaders, but that's still like very limited compared to something like Relay. And this is my slide where maybe I bring up GraphQL, Relay, maybe even Isograph, and talk about how powerful they are, kind of what they enable, and why you might want to adopt them. So again, like GraphQL, it has to be an informed decision. This is not the one, like this is not the problem that you bring GraphQL for. You bring GraphQL for other problems, and this is kind of like an additional benefit that you get when you use Relay. And of course, if you're using GraphQL, please use Relay, and soon Isograph. Questions so far? Thoughts?
I'm taking notes as I go. We can
cool. Okay.
Yeah, finish it up, and then I'll go through the notes.
Cool. Maybe server-side rendering will help, and it certainly helps. So yeah, let's render UI on the server. Set people after looking at their SEO scores. So SSR definitely helps for initial load. We can just fetch that data on the server and send down the fully rendered content immediately. And while the client loads the JavaScript, the page is not quite in. We cannot quite interact with it, but we can still see it. And this also means that we are only going to load the JavaScript that's actually needed on the page, and we can load most of it in parallel or in a single go, basically, because we are already rendered on the server. We know all the components that are needed. And this is where my slides kind of end. There's a let it stream and a quick graph showing what we can do with streaming. Like we get the initial load immediately, and as soon as data is available, we start the server starts sending down chunks. You can also start loading your JavaScript pretty much as quickly as you have the initial document. I'll probably also update these charts to have more more labels. Like I can add some more asset fetching. I can say like, okay, here are the core web vitals. I haven't really dug into core web vitals yet at all. These are 2 empty slides, and that's where it ends. So this is kind of what I have for slides. I also have a demo, and I have some more kind of I guess some similar to these charts that I can pull up. So I was doing a lot of this yesterday. I was trying to like break down approaches to I guess like our architecting applications and what you get out of them. So for example, you can just do client rendering, or you can add hoisting to it to improve certain things, but then you hurt your I guess your DX of it, right?
Mm-hmm. Yeah.
And okay. Yeah, similar to that, you can add SSR to help your initial load, but now you have to pay hydration cost, and you're still this is still a 2.
Yeah.
And something like Relay, it brings in a lot of stuff to help with this. You can combined with its hosting and caching abilities, you basically get the best navigations out of everything. And because you have GraphQL fragment composition, your solution is very composable. You can declare your data dependencies pretty much anywhere. Here, what did I do? Oh, I added streaming here. So yeah, you can most meta frameworks these days support streaming in some way. I'll bring up the examples of Remix and SwellKit, where you can return promises instead of awaiting them from your server loaders. So and instead, do you know about how streaming kind of works in stuff like Remix?
No, I don't know how it works in Remix at all.
So basically, what you do is, if I go back to so this example here, I'm not awaiting it, but let's say you have like 3 different calls. You would either have like await promised at all, and you put all 3 in there, or you would await each of them separately if they somehow depend on each other. But what you can do is just return the promise. I'll actually bring up the code example. Give me a second. I'm going to stop screen, and I'm going to share my entire screen. This one. Okay, cool. So where was I? Let's show some examples. So I have this running. I'll also go over my demo quickly. So I have 3 demos here. One is where the typical where we query in our component, and that's when it starts fetching. I'm going to click on that. We basically see loading for a while, and then everything kind of like as we have the data, we render it. But we can see that these 2 are loading, and this only starts loading once this is rendered. So this is an example of the data waterfall. We can go to this. We see the same thing. We first render everything and start fetching. And once we have the data, we show the UI. And I have 3 pages in here. There's the account, the product, and the kind of home page. This is the client loaded demo. If I go back, there's a hoisting demo where you saw that the screen was just stuck and then it showed the whole page. Same thing here. See the URL changed and we just see the new page. So this is kind of what we get with hoisting. And let me dig into the example for this. Yeah, so all of these are built in built-in server components, but you can kind of see the idea. I should probably return this as a loader, but that's kind of what you do in like a loader function. I should extract this out here. Export function loader, and I can do just this. Oh, this is an async function. And I can just return all that data. And then I'll have access to this data in here. Now, again, like in an actual framework like Remix, you would use loader data. And this will not be a server component, but I'm kind of like emulating that pattern in a server component framework. Right. And how you would do streaming with this is you can actually just like remove the await. You can make this a promise. So you get like all 3 of these are now promises, and you wrap it in something like deferred, which you would get from Remix. So now you can like return promises to the client instead of awaiting them here. And in here, you can add suspects boundaries to make sure that the data that you want is available before you start rendering.
Mm-hmm.
And if you want to block on something, I can like type await here, and now this is no longer a promise. So we'll now wait for this to finish, then we show the page, and the data for the other 2 get streamed in. So this is a really nice, I guess, kind of a nice pattern, but it still requires hoisting everything. So I still need to pull all the data fetching outside of my components, put them in loaders, or whatever the framework's version of loader is, and either I return promises from here. I think SvelteKit allows you to just return the promise instead of wrapping it. I think Remix is also working on getting rid of that, but the idea is generally the same. Right. So yeah, so that's how we get from here to here. We can use a framework which gives us streaming capabilities. We can improve a bunch of these, mostly, I guess, initial load. But these 2 kind of also lead to this solution here, which is server components, where you can see we brought back composability with the help of the compiler. And we still have all the nice metrics. There's also a parallel world where people were building just MPAs, and because interactivity was not really like the primary, their primary use case or like goal, performance still was. So they tried to they tried to improve their performance with streaming. Here, I can also bring up some old blog posts that like Marco has for talking about async fragments. But again, we're not interactive. And if you try to make it interactive with something like islands, so you have async fragments, and here you have interactive fragments. But again, you heard the composability, because those, you're now dealing with two separate systems. You have a server framework thing, some UI rendering on the server, and you have whatever you're using for your islands, like React, Svelte, Vue. You could be using anything, but you have two different systems to now build on top of. So you have the nice performance, but you're not composable anymore. And again, this also kind of leads to the same solution as server components, because server components are basically the same thing, but we add, like, if you see, the difference between these two, we have a compiler and we have a serializer to fix these two things. That's really the main difference between these two. Architecturally, they're very similar. So I still have to figure out how exactly to put all of this into my talk, into my slides. But that's kind of, I guess, the second component. I don't know if I even need to go into all of this detail. I don't know how helpful that is. And I already showed you the demo.
Cool.
There's a final demo here for server components, where I think I have a top level suspense right now. Product, oh no, index. Get out. So let me get rid of this suspense. Okay. So now this actually acts a lot more like hoisted fetching. See, the URL changed, but we only see the whole thing once all the data is available. That's the default. And at any point, I can add suspense boundaries, like let's add it around the featured product. And oops, refresh. Now we see this immediately, but we're waiting for all of this to show up. And I can keep adding suspense. Like I don't think I need to explain suspense to you, but this is where I go on a slightly longer rant about basically like what you can do with suspense, and especially when combined with streaming, because you don't only use suspense to show feedback, you also use suspense to kind of delay something that might be taking a long time, or that could take a long time, which is not something you would traditionally do in client. That's basically everything that I have right now. Still have to fully structure it into a 40-minute monologue.
Okay, yeah, this was awesome. I think that this is, I mean, obviously you're not giving it in the form of a presentation, but if I imagine a presentation version of this, I actually really like it. So
thanks.
Anyway,
given that I can live up to that,
yeah,
the presentation quality.
No pressure. Yeah.
No pressure.
Okay. I think that the one thing that I'm missing is like a pretty clear discussion of the problem,
right,
and of the forms which the solutions take. So let's start with the problem, right? Like I really want something where it's like, you may need to load some JavaScript. You may need to load some data. That causes the component to render. Then we load some additional data, because only then we discover that we've made the network request. And like really just like, because your whole talk is premised on like people understanding network waterfalls, both data and JavaScript waterfalls, I guess, and also being convinced that they're bad. Right? Like knowing that we should try to avoid them. So I think it would be really helpful to just have like before we really get into solutions, just like a discussion of what exactly is happening. And I think like the key things are that you need to download the server needs to respond to your initial query, send you something. You need to parse and execute that JavaScript. Then you start a network request. Like that's sort of the initial, like that's like the SPA idea right there, right? And it was confusing to me when you talked about like JavaScript to JavaScript waterfalls. Like I'm not really sure how those would occur. Like I mean I can make scenarios up, but like I don't know what scenario you have in mind. But like I would imagine it's that like you render a component and discover that you need a asynchronously imported component and start the request for that one, and so on and so forth.
Right.
Which it's not clear to me that that's like something that people actually do. I mean, I don't know. Is it? So
the JavaScript to JavaScript was only relevant for initial load when you don't have any JavaScript running. So you fetch the first, you get the first like HTML document, you load like the very first bundle, but that very first bundle is just your router. It doesn't have like any actual React components for the current page because you code split that. So once you load the router, you start the router. That's when you see, okay, this is the component that I need to load for this page. So that it's only really relevant for the very first page load.
Okay, cool. Yeah, that makes a lot of sense. Yeah, I think this would benefit a lot from just like a very explicit discussion of like, here's what we were trying to avoid. And also, I mean, I think network waterfalls are probably the most relevant one. Like nested, nested components, each making their own data, or each fetching their own data. And so I think that would like spend more time discussing exactly what's going on there, because that's like that's the foot gun that people run into, I think, most of the time. And it might be helpful to look at, I don't know, some banking website, like the network tab on some banking website, and you'll just see exactly, like it's really obvious that there's a network waterfall going on, because like one request will end and then another one will start and then so on and so forth. And like, I don't know, maybe you just go check out like the top 20 banks. One of them will have like a 50-page waterfall. The problem is like maybe the waterfall only occurs if you're logged in. So I don't know. I
can also like twitter.com is or I guess x.com is a good example of that. The first time you load up, you'll probably see like 5 loading spinners for like you'll see the initial page, and then you'll see 5 more for each section.
Yeah. Okay. So more
also like I've built apps. I've built apps that do waterfalls.
Yeah, it's the convenient. I mean, see, that's I think brings up a good point, which is like there are advantages to doing waterfalls, which is that they're easy, and like, if you're building an internal app, like half the time you don't care. Like, if you're building something like Amazon, where like 100 milliseconds costs you like bajillion dollars, then like you really want to avoid it there. But like there are certain situations where you just don't care, and like this is probably one of those where you really should measure and be certain that you actually care enough to remove them. Well, I guess that gets back to like the developer experience thing. Like you really should want to remove them, but like the cost of removing them is the developer experience of removing them. So once the developer experience of removing them gets super easy, then the cost is 0, and everybody should have perfect apps forever. So, okay.
Relay, let's go.
Yeah. The other thing that I would say is I think like, well, when I talk about exactly this subject in my presentations, I always like distinguish between every component fetching its own data and every component and writing a single query for a given page. And I think that would be a helpful distinction for you to make. I don't think it's the only way to make this distinction. Like I know that in some of the relay talks from the old React confs, like the distinction isn't like those two extremes. It's like, maybe you have one query that fetches most of the data, and then like some others like custom logic or whatever. Like basically, look at when Joe talks about this. He has some nice ways to like complicate the scenario and basically say like, yeah, in practice, what you'll do is some sort of weird like hodgepodge of things like this, and this has its own issues, such as, which I think is good to mention, because like one mental response somebody might have, be like, yeah, but my app is not that complicated. Like I can manage this. And like the answer is like, yes, maybe. Depends on how complicated your app is. Like, but I think that like the most obviously like distinguishing between like one query and each component fetching its own data is very helpful. One, because that one like really shows off a waterfall, and the other one because it's, and then I feel like you should talk about why writing a single query for a given page is brittle. In particular, you come back a few months later and you're like, I don't know why this field is there. I don't know whether I can remove it.
Yeah, I was trying to get to that point with the hoisted fetching. Like hoisted is basically like writing a single query for the whole page, and I definitely need more examples for that.
Yeah, and I think that's actually like honestly kind of interesting. It's like the hoisted query. Like, how does a hoisted remix query compare to a call to use lazy load query or use preload query or whatever in Relay? And the answer is that they're very similar. And you could really make them similar by saying like, by trying to use remix in a type safe way, which is to say like you pass down, like the top loader loads everything, and then whoever depends on that data has some sort of prop, and you need to thread it down to the child component somehow to satisfy the type system. And like I feel like you could really show what's going on there, and like, you know, I mean, at least if everything is fetching its own like tiny amount of data from like the same object, like this might make sense. And obviously, like,
sorry, I was saying remix puts all the data in context, so you can avoid the prop drilling. Any component can just use loader data and use whatever data that they want out of it. So we like prop drilling is like I guess one thing that we have avoided there.
Yeah, I don't know. I mean, obviously, I disagree with the use of context, because like that makes it not type safe, and it's easy to use a component where the data hasn't been loaded. And that's a problem.
Let me show you how it does it. Oops. So if I go to server
it would be kind of nice if React tracked the context like statically somehow. I guess that would like make it basically Coca or some other like more advanced language, that something that JavaScript can't do right now.
Yeah, I mean, you should. Do you know about random side note? Have you seen Effect.ts?
Yeah, I've seen it making the rounds. Yes.
Yeah, I saw it on Twitter somewhere. Effect basically has type safe context, so you can say that certain effects depend on like something to be there in context, and the TypeScript will yell at you if you haven't provided it. So it's pretty nice. But cool. How Remix does it is you use the hook, and then you pass in type of loader, or maybe it's type of return type loader. It's something like that. Like you have to manually. No, it's just type of loader. Yeah, so you have to like tell the hook that here's the loader that I'm using, and give me the data for it. So it's still it's still not great, but I guess it does something.
Yeah. Okay. Yeah. So anyway, for like a simple example, right? Like let's just assuming we can sidestep the issue of prop drilling because we only have like 2 levels, right? I think it would be elucidating to do something like where each subcomponent specifies the data it needs, receives it as a prop, and therefore that forces you via the type system to start fetching some data in the loader.
Right.
And that's kind of like the best of both worlds, relay kind of world. And I think that it would be useful for people to see that, so to intuitively understand, like, okay, why are we taking these shortcuts with Remix? And the answer is like, threading stuff down like that or whatever is really annoying. And yeah, okay. I guess this all fits under that meta point, which is like, I think your presentations spent a good amount of time talking about specifics rather than like talking about like the overall problem of and what we were trying to avoid like abstractly.
Yeah, I tend to fall into those sometimes.
Yeah, no, it's all. I mean, it's just like that's the natural way of writing things. And I think like every single time I see somebody give a presentation, like a dry run of a presentation or something, the feedback is always the same. It's like talk more about what the problem is, talk about why I'm here, which I think like also probably is good advice here. Like talk about why I'm here, which is like we all want to avoid slow websites. Even if just to say like at the end of this, you should understand the different strategies and how it all fits into a bigger picture, and you know stuff like that. Okay, so yeah, that's actually that was one of my bullet points, which is that the remix style hoisting is really equivalent to making a single network request. And I think that that's like good to explicitly call out. And maybe you did. I don't really remember. Okay.
Sorry, can you say that again?
Remix style hoisting with the loader is equivalent to making a single network request for a given page in terms of the fact that they are all, I mean, all the network requests start at the same time.
Yeah, so and like, that's if you have, and like if that hoisted function runs on the server, then it basically is a single network request.
Yeah.
But if you're using a client only app, like you don't have a server like Remix or Next.js with you, then the loader is just a function that can run before your code is loaded. You're still making a bunch of different CDP requests. But yeah, you can kind of think of it as a single request.
Yep. Might be helpful to also talk about what is it like get server side props or get static props or whatever the Next.js equivalent.
It's the same as loader.
Yeah, yeah. I think it might be good to point out that those are similar conceptually.
Yeah. That's yeah. Okay. Cool.
Yeah. I think that. Oh yeah. Okay. You talked about what the arguments in terms of co-location are for co-location. I'm sure you will come up with plenty of arguments, but like I think the best one is that you can move fast, and like nobody has to coordinate anything because you just have to reason about a single file. Like if this file fetches its own data, pretty easy to look at it and say like I have all the fields that I expect. Right. And also the type system will also tell you you're not fetching the first name, you're just accessing this variable that like doesn't exist on this data object. So yeah, I think that's a good argument. You might want to, maybe it would make sense to compare this to like microservices where like every team can deploy independently. And here deploying is like shipping to production, but like in the front end world, deploy means like merge to master. And if you, so everybody can like merge independently, everyone can deploy independently, whatever. Okay. Yeah. So I think we have a lot here to go on before we even get to something like pagination or anything like that. So I would consider whether this is enough content for a presentation before you even really get to pagination and the client-side navigation and stuff like that. But like, I don't know.
I haven't talked much about pagination. Like, how does that relate into this?
I just remember you talked about you brought up pagination later in your thing, and fetching additional data. I thought you did.
I brought up navigation. So like navigating through client-side navigations. Yes.
Yeah.
I mean, yeah, that's in my head like a very important part of like just initial load is definitely not enough. Otherwise, like we would just SSR everything. But even if you server render, that doesn't help navigations at all. So you still have to hoist up to get efficient navigations.
Yeah. So navigation, right? It's interesting. Like I feel like you could probably like really bracket all the client-side navigation stuff because it's a separate problem, right?
Okay.
In the sense that, and I think it's analogous to the following. Like you can start a network. Well, when you're doing a client-side navigation, you could potentially download less JavaScript because you have some of it, right? And if you are fully server rendering everything from a blank slate, you don't know what the user has. So you can't avoid sending them down another copy of moment.js, right? And I'm thinking a bit out loud here, but it seems like this is analogous to if you're making an additional query for a detail page, do you construct that query on the client to say like, I already have the user's name, I don't need to fetch it again. I just need the details. Like, do you do that, or do you maybe potentially start the query sooner off the server because you already have the, if you already pre-calculated with the server what the query is and like you're navigating, and so that you can start the query sooner once you kick off the request for the next page. So I think that trade-off between potentially loading less data and also potentially loading less JavaScript and loading more stuff but sooner is probably worth calling out. So like in the JavaScript case, right, like you obviously can avoid re-downloading moment.js, right, when you load the data for page 2 or something like that. And that probably requires a slightly smarter bundler, which is a bundler that realizes that you're navigating from page 1 to page 2, and therefore all the modules that are part of page 1 are already present are already downloaded. So like you can just get like the diff, which I'm really not sure if anybody does in open source. But like,
I'm not sure if
I realized as I was saying that like that actually might be something that is only doable in more complicated setups.
I think bundlers might be able to do that. I haven't looked into it, but it seems like if you're creating 2 independent let's say bundles for 2 different routes, and there's a bunch of code that's shared, you would split that into its own bundle and like point both of those route bundles into it. So again, the first time you would fetch both of them together, but when you go to a next page, you only fetch the bundle for that route. You see that, okay, the moment.js bundle is already imported. I think that's...
Yeah, but how would you do that? How would you do that across like 100 routes? You wouldn't, right?
I'm not sure.
You're either with the hey.com solution of everything is shipped independently, or like you use some sort of heuristics, like extract some stuff into a common JS bundle or whatever. I don't know.
Right.
Anyway, I guess my point is like I think like client-side navigation is probably worth it to bracket that separately and like kind of like describe it as a separate issue.
Interesting.
Yeah.
Okay.
Yeah.
So I was treating as like client-side navigation as like a big, like that's part of the problem. Like the waterfalls that we're talking about is not just initial load; it's also the navigations. But I guess like there's additional things with client-side navigations that we can do, is what you're saying. Like we can try to do more optimizations around loading less JavaScript or data.
Okay, so I mean, I guess I think that initial page load covers most of the stuff, right? Like, so you might have network waterfalls where you have to render the outer component and then the inner component, like due to like nested calls to use lazy query or whatever. You also have the situation where you need to download the JavaScript first to discover what network request is being made, and then start the network request. And so like entry points would make those 2 requests start at the same time, the data and the JavaScript. And both of those are present in both client-side and initial page load.
The entry points.
Because like if you're doing the initial page load and you need to initially download some JavaScript only to discover that on the home page you need to get homepage data, right? You need to download, execute the JavaScript, and then start the network request for the data, right?
Mm-hmm. Yeah.
But a bundler or whatever, somebody knows that like the homepage requires homepage data, can
Mm-hmm.
include a script tag like at the head that says like immediately start fetching this data, right?
Mm-hmm.
And then effectively you're starting that request for that data just as soon as you load the head of the page, which is also when you start loading the JavaScript for the
this basically requires that like hoisting, like pulling the data fetching out of the components and like putting in some sort of a loader. So the bundler has to work with the router there. But if you don't hoist anything up, you don't get that. So you now have to, like, after loading the initial bundle, you have to load the route bundle, and then you make the network request. So you already make 2 network requests, potentially 3 for the initial document, and then you make another one for the data, unless you hoist everything out into route loaders.
Sorry. Okay. So yeah. I agree with that.
Right.
Okay. You also talked about GraphQL. I mean, I think I'm obviously biased in this situation, but I think like you should really have a very concrete reason why somebody should not use GraphQL in all of this, which is like, I mean, it could just be like, it might not be for you. GraphQL solves a lot of these issues, or like maybe your backend does not support GraphQL, whatever.
Can I refer to Theo's talk?
You certainly can. Yeah. Anyway, okay, so that like gets us to where you asked for questions, I think. Okay, so from then on, I took a lot less notes, or I have a lot less to say, because like really, I only wanted to point out the like try to get you to be clear about like the underlying trade-offs and stuff like that.
Yeah, that's definitely very good to know.
Yeah. From here, I think the Excalidraw stuff that you have, like in its current form, it didn't really resonate. I thought it was too busy. Like, and I think that probably the network waterfall diagrams will work pretty well.
Okay.
I mean, you can just explain everything using those, I think.
Yeah, I do need to improve on those diagrams. I can make some arrows instead, but all right, this might work.
Yeah, I mean, it's just too much. People aren't, if people are reading your slides, they're not paying attention to you and stuff like that. And like, I don't know if it's like a super useful thing to say, to like bring up every single edge case in a conference talk in the way that would make sense if this was a comprehensive set of documentation.
Yeah, I mean, it is a 50-minute talk, so I can certainly, I think everything that I have right now, I'm probably not going to hit like the 40-50-minute mark, so I should be able to add a few more things in here if needed. But I still have to like go over kind of the history, and I have to talk about core web vitals. So those 2 things might take a bit of time. I also didn't really talk about like the capabilities of streaming, I guess. But I can just go over that when I do server components. And yeah, there's also a section on like just explaining what server components are, and the DX around them, because that's going to be very new to this audience as well.
Yeah. How does streaming relate to all? Like, what do you mean by streaming here? Is it like only downloading JavaScript or data, or which one are you talking about?
Right. So the way that I'm trying to get to streaming is, so I introduce all the problem statements, and talk about the potential solutions like hoisting or GraphQL, and I'll bring up streaming as like, hey, the HTTP streaming has been around pretty much forever, like almost 2 decades now. We've had this capability to send down like, or like from a server, send down a bunch of different chunks. But the first thing is that when we decided to do purely client-side development talking to dumb APIs, we kind of lost the ability to use streaming. We could use it for if our REST API could like stream the data. That's pretty much it. So we lost the ability to make our applications a bit more, I guess, like make use of streaming. And the other thing with streaming is that it's kind of a very primitive technology. Like you send some chunk, and the next thing you send gets appended, and then you like it's everything has to be in order, which is not really how we think about UIs. We think about UIs as like as a tree. We don't think about them as one after the other, like or a sequence. So it's tough. It's kind of hard to like take the capability of streaming and apply it to whatever we are doing with UI and with data. And it took a while to build the infrastructure around how we use the capability of streaming in our application frameworks, and then take it to the next level, how to make it more composable, which was the initial idea. So there's two different variations of like how we do streaming. Technically three if we include GraphQL. The first one is what I talked about with MPAs, with fully server rendered applications. Again, they have their own server, so they can control the streaming stuff. But they and then they developed something called async fragments. Let me find the blog post here. Here. So I'll bring up this as like one. It's pretty old. So again, the people who have been working on trying to make multi-page apps really performant have been using this technique for a while. And this takes the again, it has all the same stuff about waterfalls, or like this is not about waterfalls but blocking instead. So the idea that to show any HTML you have to block, you have to wait for all the data to arrive on your server before you can show anything. And instead with streaming, they can send down, like they send a header here, here they render something, and this is when it's fully functional. So they try to use streaming to kind of fix their so that they can send down UI early. And that's when they came up with async fragments. So instead of streaming in order, you now have a JavaScript library that is shipped to the client, and you can send these in a special format to the client, and the client will make sure they appear on the screen as they're supposed to. So this is called out of order streaming. Instead of just like streaming a sequence, you can stream a UI out of order as it is prepared. And this was kind of the like something that frameworks like Marco had been trying to build on top of. So this is one variation, and then the other variation is the one that we talked about, where you can just return promises instead of awaiting them. So both of and obviously the GraphQL add defer directive. So all of these are like they are DX wrappers around the capability of streaming. So my premise here is that streaming as a technology is very helpful, but we need a better DX on top of it. Ideally, something that is composable, and that's what server components are, basically, pretty much. Like we have these, like the server components are essentially these async fragments, something that the MPA world was doing, but the SPA world was not doing. So we combine those two, so we get async components, and we get suspense. So this is a more composable way to define what are the streaming boundaries. When do you want to stream your data? And it's also UI based instead of data based. That's a tricky word. Data oriented, or instead of and this is UI oriented. So you kind of can take a designer look of like, this is where I want loading spinner, or this is all the content that I want to make sure appears at the same time. I don't want loading spinners in between. I just want an overall loading spinner. So you can make those decisions based on your UI instead of based on your data. So these thoughts are I have these like still, I guess, disjointed thoughts. I still need to put them together in a proper monologue. But I don't know how much sense that made.
Yeah, I haven't heard of Marco, so I wouldn't. I don't know if others have or whatever, or like.
Yeah, again, this is a part of the, I guess, the history lesson. Marco was developed at eBay, and they still use it for, like, it's a very performance heavy framework or performance oriented framework because they use it for ebay.com.
Yeah, just in terms of, like, conceptually, like, I don't know if it. I feel like a simple version of React Server Components, which is like we execute your tree on the server and discover the requests that we need to start and make, is very helpful as a starting point because it really shows you that you can you can't get rid of certain waterfalls. Like the outer component must render fully before the child component starts. Waterfalls, but like you can avoid other waterfalls and add like, and I mean, I guess like I feel like the important thing for React Server Components is like comparing the hop between the client and the server and the server and the database.
Right.
Like
that's also another section that I have to add a slide for and talk about.
Yeah, I think this is an overall really good presentation. Like I think you're probably going to get at, like, once you've fully hashed it out, like really make a presentation where people can look at this and be like, at the end of this, I will understand all the different ways in which we can sort of optimize stuff by loading stuff sooner. Without necessarily, I would try not to get bogged down in the specifics, because I think the concepts are more relevant than the
definitely
specifics of how it works with Remix or whatever.
And my demo kind of reflects that because there's like 4 different ways of rendering that I've tried to demo, and all of them are built on top of server components. So the specifics are definitely not too important. It's the ideas.
That's what I mean. That's my feedback. So
thanks. That is very helpful.
I hope so. I hope it was helpful. So
yeah, certainly. I need to flesh out all the streaming part. The streaming section, talking about why that is. I try to keep, or at least this is like how I think in my head, and maybe I try to force it too much on things, which is that there's some technical capability and there's a way for us to use it, or like some developer experience on top of it that gives us access to that capability. I try to keep those two or think about those two separately and together. I don't know how much sense that makes. Like there's always these 2 parts to anything. There's some underlying technical capability that we have to try to understand, and then there's a library or a framework or a programming language that exposes that capability to us in a nice way. So that was a distinction I was trying to draw, as like streaming as a capability has existed forever, but the way we can take advantage of streaming to build more performant websites or web apps has been like either through something async fragments, something like what Marco has, or now we can do whatever Remix does, wrapping promises, or we can do add defer in GraphQL, or we can do server components. So these are like 3 different ways to take advantage of streaming.
Yeah, makes sense as a conceptual distinction. So
cool.
I don't know if it doesn't seem like a home run to me, that distinction. Fair. But so that could just be a limitation of this particular format.
That's fair. There's other things that I've applied it to. Like I have a 40-minute video on Jamstack. I started making it when Netlify declared that they're no longer going to like support the Jamstack community or whatever. And I use something similar where I talked about serverless functions as a technology, and then like the various ways where it was applied. So I think like Next.js or like what we can do with it. We can render pages. We can just respond to data requests, or we can do background stuff. And that was the model I applied. I still need to like properly flesh this out, both for streaming and for like in general how I talk about this stuff.
Yeah. All right. I need to prepare
Cool.
for a follow-up meeting. So.
Awesome. Thank you very much for showing up. Your feedback
absolutely.
has been very helpful.
I'm glad to hear it. So.
Cool. And hopefully I'll see you around at another conference.
Yeah, I hope to see you soon. Good luck at the meetup and at the conference. I'm sure you'll hit it out of the park. Yeah.
Thanks.
All right. Send me a link once it's uploaded. I'd love to view the talk.
Will do.
All right, y'all. Bye-bye.
What's up? We back. Let me get some water. Damn, really terrible viewership on Twitch today. Who is live right now? Twitch.tv. I believe Melky is live with Ryan. Prime is live. That's why. Cool. Then I guess I'll end, and I might just go and watch someone else or continue working on my talk. Oh, you'll raid with me? Nice. Thanks. How long have you been here, Kevin? Also, BroNifty, thanks for showing up in the Twitter chat. All right, I'm gonna, let's see. We're gonna raid Melky so that we can watch Ryan in the background for 45 minutes. Thanks, that's awesome. To learn for your talk too. I definitely want to see more about your talk. So we'll have to chat. We'll chat about it. What's Melky? It's just Melky. Okay, it's not Melky Dev. Raid Melky. All right. Thank you for showing up. See you all. Not Dax. No, we're Melky is live with Ryan. So technically, I want to raid Ryan Carniado. I don't know if he's still there though. Still there? Yeah, he's still there. Cool.